Hello, it's Scott Manley here, and today I want to take a look at a mod. I want to take a look at the IXS Enterprise mod, which is a Kerbalized version of the IXS Enterprise as envisaged and popularized by Dr. Harold White at NASA. Now, he has spent the last, decade or so exploring warping space using negative energy densities, and while his results have proven to be inconclusive, he certainly hasn't ruled out the possibility. Now, the whole idea behind this spacecraft is that it uses the Alcubierre drive. I don't know how to pronounce that. He is a scientist, a theoretical physicist, who came up with solutions to Einstein's field equations that describe the curvature of space-time, and said, "Hey, here's an awesome idea for traveling faster than the speed of light." And of course that became known as the Alcubierre drive. That incidentally, he is from Mexico City, which means he pretty much is probably near those guys that make that game where you launch rockets into space with little green men on board. Should have him as a guest at KerbalCon or something, if that ever happens again. So yeah, we're just trying to build this thing up here. I'm just throwing stuff on as I find it. This is the IXS Mobile Laboratory, and then you have all these various bits of instrumentation you can stick on the side. There's a gamma ray spectrometer, the Science Junior. Ooh, that is looking nice, I have to say. Oh, we could probably actually have this tank come over the edge here. This one doesn't quite fit there. We have one that is the dual technique magnetometer. That doesn't go in because it hits the thing. A carbonite detector. The IXS thermometer. That, again, thermometer does not want to fit in that space. Let's put the gravioli detector. Aha, there, we can detect gravioli in space. Yeah, I mean, obviously this is designed to make the whole thing look good. I don't know if we're really going to need these rocket engines, but yeah, I'm just going to leave those in there. After all, what could possibly go wrong? Oh yeah, we have the IXS Communotron. Anyway, the whole warp drive concept is entirely theoretical. It relies on negative energy densities, which have not been observed in nature, regardless of how many experiments that have been done, and nothing has ever confirmed it beyond anything that couldn't be explained by instrumental noise. But we remain hopeful because, warp drives would be a pretty cool thing to have. Okay, there must be this engine in here. So, there it is there. The quantum vacuum thruster. So yeah, this is the spacecraft as designed, as envisaged. You know what? I should probably give this thing some maneuvering capability while it's in space. Let's put on some fuel tanks for it. There we go. Some, not fuel tanks, some RCS tanks there. Put 6 of those around the outside and then put some thrusters on, so at least we can rotate the spacecraft. Could have some trouble otherwise. And yeah, you'll have the crew inside, and yeah, you can actually see inside of this thing, and oh look, we have Cal 7000 and KSS Manley. I wonder who they're possibly talking about there. Personally, I would trust Cal 9000 or Cal 7000 with flying the thing rather than myself. Let's close this for now. Yeah, that's it, mostly made up. Let's get it into space then. Okay, and a bit of save file editing later. I am now sitting above Kerbal, and in this nicely illuminated space dock here. It looks rather pretty, doesn't it? Obviously we've been hard at work building it, and now we're ready for our maiden voyage, so we are going to start charging the warp field generators to generate exotic matter. Now, exotic matter is negative matter, not to be confused with antimatter. Negative matter has negative mass, antimatter has positive mass, although the jury is still out on whether antimatter actually falls down or up. But most people believe that it will fall down, but nobody's actually proven it because it's very hard to get antimatter and not have it instantly annihilate. Anyway, now that's powering up, let's take Bill Kerman out and have him do a little EVA. Now, of course, he comes out inside this little foyer there. Yes, KSS Manly. Yeah, if you want to see your space mod covered by me, then yes, putting the name Manly in there is probably going to work pretty well. Okay, we can see all the stuff there. Cargo bay, and then we have this door we need to open. Open the pod bay door, Bill. I'm sorry, Bill, I can't do that. Of course he can. Okay. And we zip through. Let's turn on the lights. We can see this in the background. Oh, excellent. Look at this. Now, the warp drive rings, the Alcubierre drive rings in the original Interstellar mod, they had colliders that meant you couldn't fly through them, but apparently the developer of this has fixed that particular thing. Although I wouldn't necessarily recommend flying through those while it's working. It might mess with your head a little as you, as space-time essentially gets stretched around these things. There we go, zipping around. This is of course the main fuselage section. I don't know why I put fuel on this, because I have nothing that I'm going to use it for. Space dock looks pretty darn nice as well, with all those extra lights and everything, huh? Okay. Oh, is the sun rising? Can we watch sunrise in orbit? That would be pretty cool. Let's fly backwards and just watch as sun rises. It's surely about to happen. I know. Oh, look at that beautiful arc as the sun starts to illuminate the atmosphere curve. And I don't think I have any the atmosphere modifications or anything on this here. There we go. Oh, brilliant. Now he's just blinded himself, of course, because he's looked straight into the sun. Okay, let's get back inside this and prepare for our maiden voyage. I'm sure things are starting to charge up, and we're going to get ready to actually use some of that exotic matter to move really fast. Okay, get in. I also like the red and the blue it's science instruments. They really give the spacecraft an interesting look from the front. Yeah, you see red on one side, blue on the other. Probably not standard, but who cares? Okay, so I'm going to undock this, decouple, and now Starfleet regulations say you're only allowed to use thrusters in space dock, so we're going to activate our quantum vacuum thruster. Quantum vacuum thruster is another theoretical device which is actually in some ways strangely related to the warp drive. So this pushes against the quantum vacuum or the 0 point energy, depending upon depending on what you want to call it. And yeah, you know, quantum vacuum is where essentially the vacuum doesn't have zero energy, and so in theory you could push against that, maybe or maybe not. People have postulated it various ways. People also postulate that you can actually grab 0 point energy, although that has the problem of 0 point energy essentially being the lowest energy point. And the only reason there's energy left in it is because of the Heisenberg uncertainty principle. So if you want to get the energy out, you pretty much have to violate the Heisenberg uncertainty principle. And Heisenberg doesn't like that happening. You know, it's kind of a fundamental thing. Anyway, we're going to close this here. Yeah, I mean, there's a whole funny thing to talk about the quantum vacuum. It's called the vacuum catastrophe, which is called the least accurate prediction in the history of physics, right? Let me just explain this as I prepare the warp drive. We're going to head out somewhere. Where can we head? I'm just firing up my engine, but... oh, look, Eve is practically in the right location. So yeah, quantum vacuum is something that gets predicted by quantum mechanics, and in particular, quantum field theory is an exceptionally successful theoretical framework for modeling particle physics, i.e. how things behave at very short distances. The problem is that it predicts like a background energy called 0 point energy, and it predicts a lot of it. Now, general relativity then says, well, if you've got that energy, then it must generate gravity, and also it has to generate pressure that will expand the universe. Well, we can measure the expansion of the universe, and its prediction, or it's the experimental answer for the amount of vacuum energy is a lot less than the theoretical prediction from quantum field theory. Okay, so we've got this lined up. I'm going to shut down the engine and prepare this to fire. So we're going to activate warp drive. Now let's just see actually how far we have to go. Oh no, it's about 9 million miles. You know, it's going to be a little while. So activate warp drive. Activate this warp drive, and now this is at warp speed 0.1, and all we're allowed to do is slow down, not allowed to speed up. Well, maybe once we get going a little faster. I don't know, we're travelling at 0.1 C and we've just crossed the sphere of influence. I should have looked backwards and watched Kerbal disappear. Never mind. Let bygones be bygones. Okay, so moving at 0.1 C. According to this, actually that's 0.2. Both of these things are making us move fast, but we'll take a little while to get there. Okay, so the quantum field theory basically says that the energy is 10 to the power of 107 times what observations of the universe tell us, right? Now, that is actually a hard number to get your head around, right? That's obviously a 1 with 107 zeros after it. It's quite frankly a ridiculous number. It's hard to, you have these like, oh, we have to be so accurate that if we hit a baseball in San Francisco, it would land in New York. In fact, it would land on the H key of your keyboard. No, like, it's hard to actually come up with real world examples of how inaccurate. Imagine you said, oh, the universe has just one electron in it. That would still be a more accurate estimate of the contents of the universe than the vacuum catastrophe prediction is. It's called the vacuum catastrophe basically because two very powerful, very accurate theoretical frameworks for modeling the universe come to such ridiculously different answers as to the question. So it's considered a catastrophe. So one of them has to be wrong, or there has to be some modification. I'm just going to turn this thing since it doesn't seem to be turning. Just point it that way a little better and activate the warp drive again. I'm wondering when it'll show up. Ah, there, look, we're going to encounter there in 5 minutes, so I can at least do a bit of time acceleration. So yeah, I mean, both theories are really, really good, and here's the thing, right? We can also experimentally detect, like, 0-point energy, or at least the one explanation for a particular phenomena can be detected at very small scales, right? There's something called the Casimir effect, and that's where you have two metal plates, very, very smooth metal plates, and you move them very close together. And as they get very close together, what happens is they stop large photons from getting in, right? So photons have a wavelength, and the ones that are really long, right, such as microwaves are like an inch. Well, if your plates are a millimeter apart, those microwaves can't get in there, but they still exist on the outside. So there is a pressure from the outside from all these larger wavelengths pushing in, and it pretty much, the Casimir effect has been observed in the lab, and it doesn't differ too much from what quantum field theory says, I believe. I could be completely wrong in this, but I know that Casimir force exists. If you have the two plates roughly 10 nanometers apart, then the pressure you get is equivalent to atmospheric pressure. Okay, I'm going to deactivate warp drive. Woo! And now we are out of warp drive, and interestingly enough, we have suddenly, remember how we were coming in this direction? Well, now we're going out in this direction. The reason is we have preserved our velocity when we traveled over here. So we are moving this direction at about 9 kilometers per second. Now, Eve is moving in this direction at about 10.8 kilometers per second, which means I'm moving backwards about 1.5 kilometers per second. And indeed, I will depart the sphere of influence and find myself falling down towards the sun in an eccentric orbit. So of course, now I'm here, I need to fire up the engine and cancel out this velocity. So there we go. Quantum vacuum thruster. And somewhere out there, there is Eve there. So we have just voyaged to Eve in about 40 minutes. And I could probably have done it faster if I decided to let the warp drives charge up. Why is this not charging? Start charging. Start charging. Yeah, there, let that go. Yeah, so that is the IXS Enterprise, a Kerbal version of an artist's impression of a theoretical spaceship by a NASA scientist. It looks brilliant. I might actually just use this for whenever I actually get warp drive in my game, although I'm not sure it's compatible with the old version of Interstellar mod. So it is compatible with the Interstellar Light mod, the one which is designed to be easier for most players. It changes the laws of physics so the radiators are more efficient and adjusts the energy output of the various parts, so there's a much more logical progression. But you know, if you want, you can also get it standalone without Interstellar Light, if that is your thing. It's developed and maintained by Stevie D, not to be confused with Stevie V or Stevie B, who both released terrible records in the 90s. And it's available from the forums, or all the other usual places where you get great mods. I'm Scott Manley. Fly safe.